In this session, we're going to be taking a look at network analysis. And look, out there in the real world, there's a lot more going on than just points, lines, and polygons. There's a whole bunch of different phenomena, different stuff that has relationships, it has connectivity, it has dependencies upon each other. And for us as GIS analysts, behind our computers, we often have to model those relationships and those networks for the purpose of our day jobs. And in the tool bag from Esri, on the vector front, there's a variety of different options for performing this modeling. So there's the utility network. This allows us to trace how resources like wastewater, water, gas, electricity flow through a network. We're also dealing with the types of devices that you get on those networks, be it transformers and transmission lines and fuses through to pipes and valves. Is anyone using the geometric network or has been using that before? Okay, just scanning the view. So, what to keep an eye on is the new trace network. So you might have noticed the geometric network hasn't been ported across into ArcGIS Pro in its full entirety, and can't comment too much on that, but what I can tell you is that Esri is working on this new trace network. It's essentially a lightweight version of the utility network, but wrapped up into a file geodatabase without any reliance on ArcGIS Enterprise, and it's currently in the beta of ArcGIS Pro. So if you're using the geometric network, I'd potentially start having a look at this guy, because it might be the successor to the geometric network. There's linear referencing, so this allows you to have an alternative approach for collecting and storing information about linear features. So using the measurements. So where I'm from in Victoria, our Vic Roads department use measurements along the roads to store information about their assets. And then schematics. This is about having different representations of your network. So for example, again using metro trains as an example, they would have the true geographical location of the train centre lines as a layer, but they might have a schematic to show the straight line diagrams of each of the routes and then the stops along those routes, and then they might also have a schematic that's a more generalised view of the entire train network, similar to the one that I see on our train carriages, similar to the one that's the London Tube app, for instance. But this session is going to focus on the Network Analyst extension. Now this is targeted at modelling transportation networks, and this could be anything from pedestrians being routed around a convention centre, right the way through to road trains being routed across Australia. Network Analyst includes a range of tools. These tools are called solvers. They allow you to work for problems like coverage, so identifying the percentage of your citizens that are within a given distance or time from your facilities, be it open spaces, or dog parks, or libraries, or basketball courts. It helps you with optimising your work order run sheet with your field crews. It helps you with site selection decisions. The solvers will also help you do closest facilities, so perhaps you, as work orders pop up into your system, automate allocating them to the nearest available field crew using the closest facility solver. And then also more in-depth origin destination studies, be it customers and bank branches, or again, your citizens and your facilities at a finer level. Now everything revolves around this network data set. This is how you define how everything is connected. It's how you set up your restrictions. This could be the height restrictions and weight restrictions, making sure pedestrians don't walk down highways, making sure the cars go the right way down one-way streets. It's where you set up your hierarchy. So as a push bike rider, my preference is to ride on a dedicated bike path first, and then a bike path on a road, and then a less busy road through to a more busy road. And you can actually bake that preference into this network data set. And what is the cost you're trying to minimise? Is it typically shortest travel time or shortest distance? And then wrapping up a whole bunch of these settings into simpler travel modes so that the end user can just pick drive time or walk time or bike time. A network data set is as good as the data that feeds into it. In this session we'll actually take a look at the various different data options for Australia that you can incorporate into a network data set. And traditionally, as a GIS analyst, what we do is fire up ArcGIS desktop and then use the tools and the solvers directly against that network data set. But there's a growing appetite within your organisations for consuming these types of capabilities from other client applications. So what you can do is you can take that network data set, so let's say it's StreetMap Premium, and you can publish that to ArcGIS Enterprise. In fact, there's a tool in ArcGIS Enterprise that will publish that data set into a series of analysis services. So you can allow an urban planner to do some drive time analysis and insights for ArcGIS. You could allow a data scientist to spin up their own Jupyter notebook
and do some analysis using closest facility or origin destination. Or maybe you just want to consume the services from your other business systems. So hitting the APIs perhaps from custom apps or maybe from a GeoCortex workflow. You can do that when you publish these capabilities as web services. Maybe you don't have Network Analyst, and that's fine. So you can actually use the online analysis services. So from a data perspective, it's the here 2019 Q1 data that's in StreetMap Premium, that's in these network analysis services, and you can use these within ArcGIS Online, from ArcGIS Desktop, but you can also proxy these services into your ArcGIS Enterprise so that your other applications on your own infrastructure can use these services through this kind of hybrid approach. So let's take a look. I'll show you using these online services, first off within ArcGIS Online, and then we'll jump into ArcGIS Pro and use them from there. So the simplest form of network analysis is just doing some routing. So just to show you some of the options, if we just plug in some places, so we'll put in Convention Center, where else? Suncorp Stadium. So this is just using the geocoder in ArcGIS Online. It's just, I'm sure there's better places to get coffee, but the nearest Starbucks and story. So nothing really that spectacular here, but once you've plugged in these destinations, the geocoder, the routing service will then calculate the route between these destinations. This is the travel mode here, so we can change the travel mode from driving time to walking time, and different hierarchies and different restrictions come into play, so the route changes, and obviously the time to complete that route will get larger. We can also ask the algorithm, look, I need to actually get back to the convention center at the end, do a round trip, and you tell me what's the best way of optimizing these stops and recalculate that. And a really important one is incorporating traffic. So let's say we were to leave, let's say at 6 in the morning. We're going to get a very different result if we leave later on. So at 6 in the morning, the route actually changes a bit to accommodate the congestion at that time. So the roads are pretty free-flowing at that time. Whereas if we jump to 8 a.m., so we can see there that the roads are pretty green at this time, but if we jump to 8 a.m. and ask the algorithm to recalculate that route, the travel time will increase, and the route's pretty much still the same, and we can see that the traffic on the roads is more congested at that time. So I wanted to show that just because traffic does really change the answer to your result. Now going back to these travel modes here, the out of the box of ArcGIS Online, most of the travel modes are sufficient for what you might want to do. But what a lot of people don't realize is you can jump into the admin settings of your account and you can configure your own travel mode. So down here, I can take one of the existing travel modes. So I've taken there's a out-of-the-box trucking time travel mode. I can copy that and tweak it further. So what I've done is I've tweaked this to be what's called a Class 2 heavy vehicle. And in here, I can change some of the restrictions and some of the hierarchy of this data set without even jumping to ArcGIS Desktop. So from memory, what have I done here? I've changed. There's a height restriction of, there's a height restriction of 5 meters. There's a length restriction of 20, and there's a 4.5 ton limit to this travel mode as well. And this carries across into your routing. So this is a notorious bridge down in Melbourne that's only 3 meters high. A lot of vehicles encounter it. And if you're the one doing the routing, so let's say you've got a vehicle up here on Munro Street, and you've got to route them down to, let's say, York Street. By default, the out-of-the-box driving time will, I'm assuming, go straight under that bridge, and that makes sense. But if they were driving a Class 2 heavy vehicle, that would be a bad move. So using that new travel mode, without publishing any services, we can actually take into account that height restriction, so it will route them around that particular tunnel or bridge. This is the LGA that I'm from. And these are the election booths in my neighborhood that I can go vote at. And the question I've been asked is, well, look, we have these new candidate locations that we want to incorporate 2 of 2 out of these 5 we want to incorporate into this election booth network. So, without even jumping into ArcGIS Desktop, I can actually jump into the analysis tools, and using the choose best facilities, there's a few options here. And what I really want to do is just maximize the coverage. So make sure that the most amount of citizens can actually reach these election booths. And just actually backtracking a little bit, this population in this area is not flat. So the population, as you'd expect, changes over the area. So these SA2s with the voting population within it. It's essentially a supply and demand kind of type question that we're trying to solve here. So what I want to do is maximize coverage. I want to make sure people can walk from their house to the election booth. The demand is not flat. It's actually based upon the population demand, and it's from this field called voting population. The travel range is static, so that I just want to say 15 minutes. Any more than that, and I'm going to assume that they're not going to turn out to vote. The required facilities layer, and then the candidates we're looking at, and we just want to choose the top 2. So if I get that crunching, that'll use those online network analysis services to create this result. Just backtracking through a result that I've already pre-cooked. So here we've got the final result. So out of those 5, these ones at the top here are the ones that win, and these other ones down at the bottom are actually the ones that don't win. And it's basically because of the population that they serve. So looking through some of the other results that get created, we can actually see that up here in the northern area, there's a lot more population that these 2 would actually service, whereas the ones down here at the bottom, there's already an overlap with the other election booths that are in that kind of 15-minute walk time. So the algorithm decides that these 2 would be a better choice to accommodate more people. So over in ArcGIS Pro, logged in to ArcGIS Online, from the analysis ribbon, we have these ready-to-use tools here. So from these ready-to-use tools, at the bottom, even without Network Analyst, I have the ability to perform network analysis from ArcGIS Pro. So what I want to do here is I want to create a distance matrix between all of the capital cities, so I can create one of those kind of atlas distance matrix that you used to get in the back of a road atlas. This would be a origin destination layer, so we create origin destination cost matrix. And the origins and the destinations are essentially the same, it's just the capital cities for both. Come on. You do have to be signed into ArcGIS Online, otherwise you won't get access to the services, but I believe I'm signed in. Okay, so the origins and destinations, the same. I'll leave the travel mode as default, but I will say in the output, I'd like to generate some straight lines between them. We'll get that running. It'll probably complete as I show you some other results. So these are the results of that analysis. So whilst these are lines, it's not actually a straight line. So the line is more of a representation of what's between these 2. So between Perth and Darwin, it's actually calculated the total travel time, the total distance along the road network. It's just represented by that straight line between them. And then we can use this layer. It's really the attribute table behind this layer that I'm interested in, because that gives us the distance matrix between the cities, and we can then use that information in charts and also the map as well. But what happens if, in this example, I've got over 1 million buildings, and I've got these just over 100 fire stations, and what I've been asked to do is, for every single building, calculate what's the nearest fire station to it, and what is the travel time from that building to that fire station. Now, whilst I could use ArcGIS Online to throw this out, it's going to use up a fair bit of credits to calculate that, and if I wanted to do a number of iterations, it is going to use a fair few credits. So what I have here in the map is a network dataset called StreetMap Premium, and I can add again, this conundrum is actually going to be solved by an origin destination. And this will create an analysis layer. And this is similar to what the other solvers do. This analysis layer allows you to import features to work with, to tweak the analysis settings, and then run and iterate through a number of different settings so you can keep calculating results. And this analysis layer is kind of created in your home geodatabase for you to kind of use as kind of like a Scratch workspace. So with this origin destination cost matrix, the ribbon will notice that there's a new layer in the map and should change to show us some settings for an origin destination cost matrix. I would import the buildings as the origins. I'd import the fire stations as the destinations. The drive time mode, I've actually got here a Queensland fire truck driving mode. So it's just got some changes to the restrictions and also some overrides where we wouldn't be able to do, but a fire truck's allowed to do certain things that we wouldn't be able to do on the road. It's the first fire station that we come across, and we would specify a time window or a particular date and time. And in this case, I wouldn't generate lines just because of the amount of data there is. I don't need those lines. All I'm actually interested in is the final attribute table that gets created, and that attribute table can then be joined back to the original buildings layer. So I can then see, okay, well, for every single one of those buildings, what is the travel time for them? And then really what we're looking out for is the ones that are in blue and purple, because these ones are going to take longer to get a fire truck out to them. It's not just about the travel time. We also can use these results to understand, well, now we have the idea of every single fire station assigned to the building. We can actually use that to start generating these kind of territories around the fire stations to understand, well, look, if this building needs a call, this is the nearest fire station that we should send to it, and maybe aggregate that data to something like mesh blocks to create some territories around. So ArcGIS Online and those analysis services, they work off a transaction credit-based model. And the commercial data sets and the network analyst extension typically work off an annual maintenance-based model. So as an organization, you just need to think, well, how many times would we use these services if they were more readily available? What is the frequency that we would use them? And how many people in the business? And what's the size of the data sets that you'd want to be throwing at them? And there'll basically be a tipping point where it makes sense to move from using the ArcGIS Online analysis services to consuming a commercial data set. Now, with all that said, I also want to make you aware that Esri do a really good job of providing tools to work with open data. So I'm sure a lot of us are big fans of OpenStreetMap. And not only as a base map, Esri can provide these tools that will allow you to download the data and actually crunch it into a network data set that you can use with Network Analyst. So these tools are available for ArcMap, and that's fine. We're just going to use the tools to create the network data set and then consume it back over in ArcGIS Pro. And the two tools we care about, the first one is just the downloading of the OpenStreetMap data. So you specify Greater Brisbane, it pumps the data into a feature data set, and then you run this create network data set, and you feed it a configuration file. So out of the box, there's one for walking, for driving, and one for, in this case, riding a bike. And it crawls through the OpenStreetMap data and looks at the tags, where there's tags available for things like the road condition, one-way streets, speed restrictions, height restrictions, and all that stuff, and applies that into the restrictions and the hierarchies of that network data set. So for Greater Melbourne, it took less than an hour to actually download and create that network data set. And it's a really good way of getting started with Network Analyst without having to purchase any data. So this is down in Melbourne. This is what we're seeing in the background here is the OpenStreetMap data. And what we have here is a service area that's using the bike mode. So this is from the convention centre in Melbourne, and a 30-minute kind of catchment around it. So that's how far we could get within 30 minutes. What I quite like to do with service areas, instead of using polygons, using lines to generate the actual output, because the lines are essentially less generalized than the polygon output. So you can actually then see with a service area that uses the lines as the output, which are the actual specific road segments we could actually get within, 30 minutes or 40 minutes from that convention center. So it's a slightly different looking result as well. I think aesthetically it looks a little bit nicer than the polygons. But you can also see a lot of the areas where you wouldn't be able to ride a bike that are actually kind of covered up with the polygon layer. Bear with me. One thing I noticed is you can also tweak it further and incorporate a little bit more hierarchy, but out of the box the tool does a good job. So I know you guys might not be too familiar with Melbourne, but I know that a lot of these parks, they're grey for a reason because you're not allowed to ride in those parks. So the OpenStreetMap data has all of those restrictions about where you can and can't ride a bike. So you shouldn't be riding in here, and it's taking that into account. And what I'm really impressed about, actually, from an OpenStreetMap perspective, is the coverage. So again, up where I'm a bit of a bike rider, and off the beaten track, so off the actual main roads, we can see that the OpenStreetMap data has a lot of coverage. So this is an area that, a lot of these trails, some of them aren't even legal trails, to be honest, but they're in the OpenStreetMap data, and you can really get an understanding of where people are riding and walking and hiking off the actual main road network. But at the same time, road networks are pretty complicated. You don't want to be the guy that, especially when you're sending people out in vehicles, driving around. Like in Melbourne, we have hook turns, you've got variable speed restrictions on different times of the day. You've got that traffic data, which isn't in the OpenStreetMap data. Bridges and tunnels. Like, my personal opinion is, and I don't want to make this a sales pitch, but the guys from here, they're in the business of essentially they're probably going to be driving our vehicles for us in the future with the data sets that they're compiling. The here data feeds into this StreetMap Premium product. So I'm a big fan of the here data for routing vehicles. But also StreetMap Premium is optimized by the Esri Network Analyst team specifically for network analysts. You can incorporate your own custom data into there as well. Has the historical data. You can use it with Pro and ArcGIS Enterprise. And you can also combine it with other data sets. So the transit data, so up here with TransLink, you can actually combine the timetable data that TransLink offer with a StreetMap data set. So it doesn't have to be OpenStreetMap. It doesn't have to be StreetMap Premium. It could be OpenStreetMap. And the timetable data that's in the TransLink data set, in ArcGIS Pro 2.4, you can now build a network data set that incorporates that public transport timetable data. So then you combine it with the street network and this timetable data. And what this animation is showing is it's a very time-sensitive data. So depending on what time of day it is, it'll very wildly depend on what trains are running and buses are running for how far you could get at that particular point of time in the day. You combine a street network data set, so this is getting from your house perhaps to the bus stop or to the train station, and then you combine that with the timetable data of when the buses and trains and trams are leaving and departing. The tools from Esri, the first one will create the GTFS data into a network data set, and this represents the stops and the routes and the schedules. And then the next one is to actually connect those stops to the routes. So you'll find that a station might actually be a good 200 meters away from the nearest street segment just because of the nature of GIS. This tool will sort of connect those two together to make sure you can actually hop off the street and get to the station. And then the third one will build that network data set with a configuration file for defining the connectivity, which you can tweak if you like. So let's have a look here. So this is the StreetMap Premium data that's been combined with the TransLink data. So this is the underlying, so the blue is the buses, the red's the trains, and the ferries in there as well. So we've combined that into one single network data set. So here we've got a service area layer that's showing us a 45-minute getting to this convention center at 5 in the morning. So at 5 in the morning, there's not much transit links open, but you can see there's definitely one open because there's these rings around these stations. But if we change this from 5 a.m. to, let's say, 9 a.m., I would make the assumption that at that time of the day, more transit links will start opening up. There'll be more buses on the road, there'll be more trains on the road, there's more frequency in the timetable data. Therefore, if we were trying to get to this convention center for 9 in the morning, the catchment to get there would be a much larger area, hopefully. And again, this is very time sensitive that you can actually specify a particular day. So the answer for Sunday would be very different to Friday, for instance. So yeah, this is the result of that. We can see that it's a much larger catchment. So looking at things like 30-minute cities and stuff, when you're looking at inner cities, a lot of us will use transit more than we would driving around. So it's important to incorporate transit. Another way of looking at this is not just getting to a particular destination, but here we have all of the schools in Brisbane. And if we zoom in, maybe we want to understand, well, look, what is the accessibility for getting to schools within a 15-minute window around them? So this allows us to understand, well, look, within these catchments, this is a 15-minute catchment around each of the schools and who can get to school within that distance, or more importantly, who can't get to school within that distance. And again, because it's time sensitive, we can actually iterate through this and understand, well, look, during that day, how does this change? So through the morning, these catchments will actually change depending on what trains and trams are running. So that's pretty much it. These are some additional resources to get more information. I'll be on the Arc Lab this afternoon. The training courses are really good there. Yeah, getting started with that OpenStreetMap data and the data from TransLink, if you're into urban planning or looking at accessibility analysis, these tools are well worth having a look.